Alright, so we are now going to start section 1.3, which is experimental design. And this is actually the last section in chapter 1. And I'm going to break this up, I think, into 2 videos. So we'll talk about some experimental design and some basic properties of what you should think about with data collection. And there's going to be another video in addition to these videos about how to collect data for your project. So you'll have to do a project for this course, and you will have to be able to collect data on your own. And it's very important to collect data in an unbiased way, which I'll talk about in a little bit. So for now, let's just talk about the basic principles of designing a statistical study. So the first thing that we do is we identify the variables of interest, and we determine what do I want to know? What is the focus? Okay, what variable or data do I want to collect? And then we develop a plan for collecting the data. Okay. After we do that, we collect the data. We describe the data using descriptive statistics techniques. And then we interpret the data and make decisions about the population using inferential statistics. And after we're done with that, we identify possible errors. And this process should sound very familiar to you. If you have ever been in any science class, you've probably learned the scientific method. And this is basically the scientific method, right? So collecting data and interpreting data, and that whole process of designing a statistical study is really the scientific method. All right? So what we're going to be talking about mostly is the second step here, is how do we collect the data? And this is so important. If your data is collected incorrectly, then that could have repercussions throughout the entire statistical process. And especially when you get to this step of analyzing the data, the 5th step right here, well, that 5th step is going to be meaningless if your data is not collected in an unbiased way. If you collect data in a way that is not going to represent your population correctly, then you are not going to have correct conclusions from that data set, which seems logical, but this happens all the time. People just think, oh, I need data, and they'll just collect data, and they'll find a way that's really fast and quick. But that fast and quick way is almost always not the best way to collect the data, right? So we're going to talk about different ways to collect data and how to collect data in such a way so that it is as unbiased as possible. It's almost impossible to get rid of biases 100%, but you can get a better data set to collect, or that represents your population. Okay, so there's 4 main ways you can collect data, and in this first, we're going to talk about an observational study. In an observational study, basically, a researcher observes and measures characteristics of an interest or part of a population, but does not change existing conditions. Okay, so basically you're just observing, you're not actually changing anything. This is different from an experiment, because in an experiment you actually do change things. And to make sure you change things, you apply a treatment, and that is applied to part of a population and responses are observed. So for example, you can observe a group, and if you're just watching them, then you aren't performing an experiment. You have to actually change something. So let's say you want to see the effect a drug has on a certain illness. Well, can I just give that person a drug and see if they get better? Well, actually, no, that's still not an experiment, because you're just observing if they're going to get better or not. But an experiment always involves 2 groups. So now, let's say I have 2 people that have the same illness. One I give the drug, the other I give a placebo or no drug at all. And I want to see if there's a difference between the 2. Well, now I've actually changed something, because now I'm changing the fact that one person gets the treatment, the other person does not. That's what defines the experiment. So make sure that an observational study is just observing. Experiment, you're actually changing something, and you're usually changing something between 2 different groups. Okay, so that's where we say the treatment is applied to part of a population and responses are observed. Another part of the population may be used as a control group, which is what I said when no treatment is applied, or they could be given a placebo, which you may have heard about before, and that is a harmless, unmedicated treatment that is made to look like the real treatment. So that is what the placebo is, and again, you've probably heard about this before. There's actually experiments done with placebos. Placebos are actually really interesting. There's even placebo surgeries that exist. So, like maybe it's a neurological condition, and one person will get brain surgery, and the other person will still be cut open, but they won't actually get the brain surgery done, but they think they got the brain surgery done, and you want to see if there's an effect and a difference between the two surgeries. So placebos exist in many different forms other than just getting a new, different pill, for example. Okay, the next one. A blank is the use of a mathematical or physical model to reproduce the conditions of a situation or process. So this blank is a simulation. We often do this when it's too dangerous to reproduce the effects of a situation, or it's impossible to reproduce the effects of a situation. And the last one is a survey, which is an investigation of one or more characteristics of a population. And these are most often carried out by just asking people questions. And surveys are actually important because to think about, because when you survey people, it's important that you always have a method of follow-up, especially if you don't ask people in person from the very beginning. So when you ask someone questions in person, they're most likely to be truthful, answer those questions. But let's say you're just making phone calls randomly. Well, if you're just making phone calls randomly, most people are not going to give you the time of day. Or send out an email, for example. They won't respond to your email. You're lucky to get a 50% response rate. And that's not okay, because the people that respond probably have stronger opinions about an issue, and they will probably have a different opinion from the people that don't respond. So it's important to try to get a representative sample on an entire population, and to do that, you want to make sure you get responses from everybody if possible that you select to be in your sample. So keep this in mind, especially when you do your project, that you're probably going to be doing an observational study of some kind, or a survey of some kind. And especially if you do the survey and you're asking people questions, and you want to make sure that that survey represents your population well, and you're not getting just a bunch of people not responding to you. It's going to take longer for you to collect the data, first of all, and second of all, the data you collect may not be representative of the population. So it's often a good idea to ask people questions in person or something to that effect. Okay, so let's take a minute or so, and I would pause the video here, try to do the next 4 questions, and using the observational study, experiment, simulation, or survey, identify what's the best way to collect the following data sets. So hopefully you decide the best method of data collection that should be used for the following data sets. So the first one is a study of the effect of changing flight patterns on the number of airplane accidents. So I would say the best for this one would be a simulation, because you can't actually crash airplanes in the air, right? Unless you're a very evil person, you're not going to want to do that. So simulation, that's something that's probably going to be the most logical one to do here. What about a study of how 4th grade students solve a puzzle? Well, we're not really changing anything. We're just watching them solve a puzzle. So this is an observational study. And a study on the effect of exercise on relieving depression. So if you want to see if you ever want to determine cause and effect, it needs to be an experiment. So we want to see if the exercise actually relieves depression. So what we need to do is we need to have a group of basically depressed people And we need to have half of them maybe exercise and half of them not exercise would be the simplest way to do it. And if the group that was exercising say that they're less depressed than the group that wasn't exercising, then we can draw a conclusion from that. And then the last one is the success of graduates of a large university finding a job within a year of graduation. It's probably just easiest to ask them, right? Do a survey. You can't really observe this because unless you're going to stalk the people for a year after graduation, probably the fastest way is just to call them up and just see if they answer, or actually ask them a question in person if you can, although that would take a lot of resources. Okay, so that's how we identify what method of data collection to use. We're going to talk a little bit more about experimental design here and just some other things to consider when you consider experimental design. The first is a confounding variable. And a confounding variable occurs when an experimenter cannot tell the difference between the effects of different factors on a variable. And so basically that's just a fancy way of saying sometimes you don't know if the treatment had an effect or if something else had an effect. For example, let's go back to this effect on relieving depression, and we want to see if exercise has an effect on relieving depression. Well, let's say I break up a group. An easy way to break up the group is just say, okay, let's have all the guys go over here, all the girls go over here. Guys, I want you to exercise. Girls, I want you not to exercise. And we'll see if you guys are depressed or not. Well, that's a horrible way to do an experiment because let's say the guy group ends up being less depressed than the girl group. Well, they were exercising, and you may be tempted to say, oh, well, the guy group, because they are exercising, exercise has an effect on relieving depression. Well, no, because over that time period, they were only guys who were exercising, right? Gender, or sex, is a confounding variable here, right? Because guys may react differently to exercise and relieving depression than girls do. We don't know if that's the effect or just because they're a different sex. So the breaking up into guys and girls is a horrible idea, which is why random assignment is so important when you're talking about an experiment. You want to make sure that a confounding variable doesn't develop between the two groups. Okay. The second occurs when experiments change their behavior simply because they know they are participating in an experiment. This is called the Hawthorne effect. And the Hawthorne effect is pretty interesting. And people change their behavior just simply because they know they're being watched. You've actually probably seen this before. If you have ever been in a room where a teacher was being observed, perhaps by an administrator, for example, everybody kind of changes their behavior. You notice maybe that the teacher's trying to do something that they typically don't do. They maybe try to be a better teacher a little bit. The kids are maybe change how they're acting. They may not, the troublemakers may not be not making as much trouble as they used to in the class. Everyone's more quiet, more well behaved typically. When an administrator's being in a room, they're more likely to answer a question if they're called on by the teacher because everybody wants to look better. The administrator's in the room. And so this is why, teacher observations, just a couple times a year typically aren't that great way to evaluate teachers because it'll typically give them a better rating than what they typically have because of the Hawthorne effect. People change how they act. So let's see. The blank occurs when a subject reacts favorably to a placebo when in fact he or she has been given no medicated treatment at all. So this is the placebo effect. And you think you're getting better when actually there may not have been anything wrong with you in the first place, or maybe you are getting better, but just because you think you actually got something that actually helped you. And you can use a technique called blinding to minimize the placebo effect. And blinding is a technique when the subject does not know whether he or she is receiving a treatment or a placebo. And in a double-blind experiment, the treatment experiment. Neither the subject nor the experimenter knows if who's receiving a treatment or a placebo. Now you might understand why they would do blinding for the subject, right? Because if you're receiving a treatment, you want to make sure that if you're receiving a treatment, you want to make sure that you don't know if that's the actual drug or if it's a placebo. For example, it might be a pill that has a treatment, or it might just be a pill with like sugar in it. It's a sugar pill. And basically, if you know, then that'll affect what you think about the condition that you have, and you'll think you're getting better when in fact you just got a placebo, right? If you know if you got the placebo. So we want to eliminate that from the equation. Now, double-blind, and actually all FDA drugs have to be double-blind experiments. An FDA-approved drug have to be approved using a double-blind experiment, and that's because the experimenter may only be interested in who got the actual treatment, but they want to make sure every subject is treated equally. So when you do these double-blind experiments, you actually have the experimenter not knowing and the subject not knowing who gets the placebo and who gets the actual drug. And then finally, and I kind of talked about this already, randomization is a process of randomly assigning subjects to different treatment groups. So that's why it's important. We already talked about why this is important, but it's basically to eliminate this confounding variables. So we want to randomize to eliminate confounding variables in an experiment. Okay? So those are just some principles of experimental design and some things you might encounter and watch out for. Okay, so that's basically experimental design, and for the next part, we're mostly going to be talking about sampling techniques. And so I think I'm going to stop the video here because I've already been going for a little bit of time, and then you can watch part 2.